Hello, glad to see so many people this morning. We are, well, hopefully you guys finished your last homework last night. So that's kind of nice to be able to know that you don't have any more homework assignments. So what we have left, or what you guys have left, is the Chapter 7-8 test, and then the final. So I finally decided, I have the Chapter 7-8 test up. I finally made a decision on how I wanted to do it. And so I thought I would let you guys, I'd clue you guys in on that. I decided that what I would do is I would, it was a little time consuming, but I think it'll work better. I wrote out for the, well, for the confidence intervals, let me start with that. So for the confidence intervals, it asks you to list out like what's the X bar, like the sample mean, what's the either the mean or the proportion depending on what kind of problem you're doing, what's the N, the degrees of freedom if you need it. So it asks you to kind of list out all those different variables, and then it'll give the actual confidence interval. And so what I decided to do was give basically there's four, for the confidence intervals, there's 4 wrong answers. Let me pull something up so I can write. And share my screen here. What happened to paint? There it is. Okay, can you guys see my screen? Awesome. Okay, so what it has is it has the the problem out for the confidence interval, and then it'll say it'll give you like 4 choices, and only one of the choices will be right, but it'll be like all complete. Like I can't remember exactly what I have in the directions, but it says like for A, list the X bar. Wow, I keep writing backwards today. What happened to me? Okay, so for A, list the X bar. B, list the N. I can't remember if this is exactly the same order. For C, list what the degrees of freedom is. It asks you like a few things to list, and then you'll have 4 choices, and each of the 4 choices will have like everything listed out. I shouldn't write ABC because the choices don't actually have ABC. They're just there. If you remember from the last test, it's not enumerated. But you'll have one that'll have, this A, B, C, D, E, and then you'll have another one that has this A, B, C, D, E, and I'll have 4 of those, and you have to pick which one's right. So do you guys remember from the last test where I gave you like 4 graphs and only one of the graphs was correct? But you didn't have to like make the graph yourself? Yeah, that's what it's going to be like. So for the confidence intervals, it'll have, those things listed out, and then in the very last answer will be like actually what the confidence interval is, and you just have to look for, out of the 4 choices, which one is correct. Now, what I would highly recommend when you do that is not even, and I said it even on the test, is I would not even look at the choices. I would look at the problem, work it out, and then go look for the correct answer. Because otherwise, looking at the answers, you're just going to get all confused. So I would just not even look at the answers, work it out on your scratch paper, and then look for which one is correct. And if one's not correct, same thing. I wouldn't necessarily start looking, trying to figure out which one's correct. I'd go back to your work and see if you made an error, and go from there. So, and I even did it so that, like, let's say one was supposed to be a T and you chose a T and you did a Z. I still gave you partial credit if you picked that one and it had all the other stuff right. So it's not like an all or nothing. It's not like I picked the right one or I picked the wrong one. So if you picked the one that it was wrong because there was a Z chosen instead of a T, you'll get like 2 out of the 3 points, that kind of thing. So anyway, that's how I decided to do that. And then I did the same thing with the confidence interval. So for the confidence interval, I I literally wrote out 6 different, like, I know the common errors that people make. So I literally wrote out 6 different complete hypothesis tests for each of the hypothesis tests that you have to do. And again, I would just not look at 6 choices. I would look at the problem, do the hypothesis test on your paper, and then look for the one that's correct. But out of those, there's 6 choices because there's so many, you know, there's the 5 steps to it. But I just didn't want to ask. I knew if I tried to like do a fill in the blank with the hypothesis test that somebody, you know, I'd put that the answer should be this and somebody would forget the colon and they'd count it wrong. Or somebody would accidentally put a P instead of a mu, or they'd put an M instead. You know, I mean, there was just so many things that could go wrong with fill in the blanks. And I really couldn't do it doesn't let you do like a drop down box like Connect Math does. And so I thought that was the best way to keep it so that it was fluid with what you guys were used to doing. So that's what I would do, is I would just work the whole thing out. And then once you've got it all worked out, look for the correct answer. Does that make sense? I think with that said, I think the test it's not as long as the last test. I mean, I think if you, there's 3 hypothesis tests, and I think there's 3 or 4 confidence intervals. Yeah, three hypothesis tests. That's it. There's 3 hypothesis tests. There's, but that's the same as I had on the written test. So it's not like it's shortened at all. And then there's like 3 confidence intervals, I think. And then a couple sample size ones where you have to figure out the sample size. And then there's some multiple choice questions. I think it's only got like 15 questions on it. But the hypothesis tests take a little bit, you know, they take longer than a regular problem. So I don't want to give you too many of them. Anybody have any questions on that before we start doing some reviewing? Okay. And again, I can't emphasize enough, I would really, really recommend that you do a problem and then look for the answers. Okay, so I wanted to look at this really quick. So, of course, this is the test that you guys already took. Don't forget that you can do test corrections. Some people were asking where to find those, and I just wanted to show really quick. I think you guys that have been coming to the Zoom classes and such may already know this, but just in case. It's hard for me to get it to give me I can view it as a student, but it doesn't look, even when I try to view it as a student, it doesn't look quite right. But let's see if I can pull this up anyway. So you pull up your test, and after you pull up your test, you go over here to this little drop down and you view submissions. Now, it's not going to look right for me because it's going to say I don't have any attempted submissions because I'm not a student. So like I said, that's where it kind of glitches up when I'm trying to look at it as a student, but I'm pretty sure that's where it is. Has everybody been able to find them okay? Okay. Has anybody not been able to find them? Okay, so I think that's the key to it, is once you get to your once you reopen that test that you've already done, you have to click on this view submissions. And so once you view submissions, it'll show you your wrong answers, and it doesn't have the answers to the wrong answers. You have to, that's part of, you know, doing your test corrections. But if you have any questions, just ask me on it. I mean, send me a quick email or something. Okay, and then there was something else that I wanted to show you, and that. Go ahead, Brittany.
These chapter 4, 6 test corrections, when did you want them in by?
I did put a date in. It didn't have a date before, but it's May 15th now.
Okay.
So
okay,
4 days.
And then this exam, this next chapter exam that we're about to have to take, those corrections are due on the 18th, right?
Right, and I'd give you more time if we had more time, but the final is on the 22nd. So.
No, that's fine. I was just making sure, because I've been getting so many things confused with all my other classes.
I know it's hard to. I was just talking to a friend a couple days ago about how it's hard to keep track of everything when it's all on the computer. It's like your brain, I don't know, when you go to class, like your brain puts that in a different place. Like I'm in this room with these people and everything, but when everything is on the computer, it's like your brain is like putting everything into the same box, and I don't know, it's like dumping everything when you're moving into the same box from different rooms, and you're like, I can't find what I'm looking for.
Yeah,
And
it's also a lot easier. This is also one of the reasons why I have such issues with doing online classes.
just keeping track of everything.
You're keeping track of everything, and you're more skeptical, whatever the word is.
Susceptible.
Yes, to being lazy and putting stuff off.
Right. It's easy because you're not right there in person, having a person tell you this is due right now or whatever.
Yeah,
Yeah.
like my psychology, my professor doesn't have specific due dates anymore for all this stuff. It's all due by the 20th.
See, and as a student, I don't do that with you guys because I know as a student I would have totally messed that up. I would have been like, oh, I could get 5 chapters done in 2 days, and I would have failed. Like, so that's one of the reasons I don't do that with you guys because.
Well, she doesn't even do what you do and like go through. We basically just have to do it all on our own. We don't have her lectures like this at all.
Whew.
She doesn't do
Not
any
even
more
recorded or anything.
No.
Oh my. So
she does Zoom if we have any questions, but other than that, we're practically on our own.
like read the book, do the questions.
Yeah.
Gosh. Well, don't hesitate to, like, if the teachers do say that they have Zoom office hours and stuff like that, don't hesitate to like use them. I mean, I can tell you that a lot of professors are like, I wish people would come to my office hours. So just, don't hesitate to do that. But at least for this class, I can tell you it is. So the corrections for this last test are due on the 15th, which is what's today, Monday. So is that Friday? Yeah, Friday. So those are due on Friday. And then the test is due on Sunday. The chapter 7-8 test, that's due Sunday night. And then you have to do corrections by Thursday because the finals due by Friday. I do not have the, why does this not have, this is weird. This is supposed to have the same directions that this one has. So I'll fix that. I don't know why that doesn't have the directions in there. But anyway, this is due the 21st because the final's on the 22nd. So so you take this test by the 17th, it'll come up to be available to see it by the 18th, which is Monday, a week from today, and then you have to have them in by Thursday. So, but this is supposed to have the same directions as this one. So I don't know. Oh, you know what? I know what it is. You guys can't see this yet, probably. Yeah, I don't have it showing until May 18th. So that's why, because I'm on student view. Hold on a second. Let me go back to regular. So once the test is passed, you'll be able to see the Dropbox pull up. I just to have it so that it's not showing until after the test because I didn't want it to get confused with this one. So after the test is passed, so this starts on May 18th, which is Monday, and then it'll have a due date on the 21st. And it's just like this one. So is everybody good? So corrections, test, corrections, test. So what's up?
Okay, I noticed on Connect Math down at the bottom of the page after all the homework, there's 2, I guess, quizzes.
Yep, I was actually going to talk about those.
Are those actually going to be graded, or are those more of a?
They're just for you. They're not graded.
Okay.
The assignment that was due last night, that was the last one that you have to do. Hold on a second. Okay. I've got a bazillion things in here because I'm the Connect Math administrator for everybody. So no, I did not volunteer for that job. Okay. So this is our class, and this one that you guys had due last night, the 8-1, 8-2, no, I guess it was 8-3, 8-4. No, it was all of them, right? 8-1, 8-2, 8-3, 8-4. That was due last night, and those were for a grade. And then these are just for practice. So it just has some chapter 7 and 8 stuff and some chapter 7 and 8. These are kind of similar. I just did 2 of them. And all it does is it has like, it just has them all mixed up. So it has a bunch of chapter 7 and 8 problems mixed up together. So I'll show you what that looks like. So it's just got 7 questions, but you don't know which one you don't know which one's going to come up. I mean, it says up here, but try to refrain from looking and just kind of, you know, try, even maybe put like a Post-it note on your screen or something so you can't see it. But as it comes up, it could be anything from chapter 7, anything from chapter 8. And so if you run through this, it might be, you know, nice. Like this would be a, obviously it's a confidence interval. And then, so if you go up here, you'll have to look and see, you know, what kind of confidence interval. And this is another good example of, you really shouldn't try, and there's no way to guess this. Look at the problem, do your answer on a scratch paper, and put your answer in here, because you're not going to know if it's correct, or you're not going to be able to guess it. So that's similar to what you see on the test. So does anybody have any questions on that, besides if it was due or not? But yeah, it's not due. And these could be, like I said, it could be anything. So there's chapter 8 ones before chapter 7 ones and everything. They're just all mixed up. And you can just work through it and try to test yourself on, can I remember if it's a, you know, when it's a T, when it's a Z, when I do proportion, when I do mean, how do I put the formula in, and all that. So there was something else I was going to show. Oh, I know. Don't forget that in the resources, you can look at, there's practice problems in here too. Even if you've never used those, this might be a good time to try it out. So you can go to chapter 7, and it's got some multiple choice test questions here at the end. So, and this would have everything. The only thing that you might run into is we didn't do 7.5. So you might run into some questions. If you see it asked for a confidence interval for a confidence interval for a standard deviation, that's the ones we didn't do. But other than that, this would be a good practice to do, because it would, again, run you through various types of problems, and it's a multiple choice, just like what you'll see on the test. So anyway, anybody have any questions on that before I close this up? Going once, going twice. Okay. And then I think that's it. Oh no, I know what else I want to show you. This was actually more why I had this pulled up. So when you guys go to the reviews in D2L, there's lots of different options. If you look here, there's actually a review for chapter 7 through 9. But then these are probably even more important, especially for chapter 8. I have what's called examples of and work desired on hypothesis tests. So I actually have, I think it's 2 problems. This is what I would have had on the actual written test, but it's still really good practice. Oh, I should put a note on this. So which one is from chapter 9? One of these is from chapter 9. Yeah, this one's from chapter 9. Notice how it has this little table over here. We never did one like that. So don't worry about C. But A, B, and D are all just like what you'll see on the test. So it'll have a hypothesis test. And then when I write it out, when I wrote out like the 6 choices, it has hypothesis, critical value, test value, and then the decision and the conclusion. So it'll look just like this. And there's a key. And so there's 3 good problems that you can just work out by hand and check on the key and see if you're doing them right. So here's what the key looks like. So on the test, it will literally look like, well, hopefully a little bit nicer written, but it'll look like this. It'll say hypothesis statement, critical values, test value, don't reject, not in, is in. It does look nicer than this on the test. I wrote a little nicer. But it'll have those things. What's the hypothesis statement? What's the critical values? What's the test value? Do we reject or not reject? So practice those 3 problems. Again, don't worry about this one because that's a chapter 9 problem. But do those other 3 and see if you're getting the right answers. I would do all 3 of them and then go check yourself and see how you did.
Is that CR where you put not in?
Yeah, critical region.
Oh, okay.
On the test, again, I made it a little bit more neat because it was, you know, a published online test. So I actually have it where it's typed out critical region.
Okay.
So all that you have to fill in is not in or in, and then afterwards it says critical region. So,
Got
so anyway, I wanted you guys to know this was here because this is great for the upcoming test for chapter 8. I would do those 3 problems and make sure that you are really confident with doing a complete one, because you want to work it all the way out and then look for the right answer. I know I've said that like 16 times. You're like, yes, we heard you. Okay. So let's go. I thought today what we do is we do a Kahoot. I have a Kahoot in chapter 7. Oh, I was going to leave open. We'll go back to it if we need it. So I was going to do the Kahoot, and then I thought after that we could do some problems out of the book if we have extra time, because the Kahoot's not very long. So once we're done with the Kahoot, we can pull some problems from the book and go from there. So hold on, I lost my, there we go. You guys see that okay? All right, so it doesn't say chapter 7. I don't think there's one that actually says chapter 7. What it says is confidence intervals. So we're gonna work on this one right here. And there's a couple problems that may not be pertinent, and we'll just skip over them. I'll recognize what they are, and we can just skip over them. So with the Kahoot, it's kind of hard for me to give you like an entire confidence interval to complete because we just don't have enough time. So I kind of tried to break it down a little bit. And again, time doesn't matter. We'll just, when the problem runs out of time, we'll just pull it back up and keep working on it. So. That scared me for a minute there. It wouldn't let me pick that. I thought something was wrong. Okay, so there's our number to get in if you want. Are those turtles?
They are turtles.
3 turtles. Okay. So I'm going to go ahead and start. This will be up in the corner of the thing if you still want to join. It's going to start off with just some really quick multiple choice stuff. So. And you guys can't hear that obnoxious music, right? You said? No? How lucky for you. I can't figure out how to turn it off. It's like blaring in my ears. Okay. So in a random sample, oh, I got to move that so you guys can see the choices. Okay, so in a random sample of 7 aerospace engineers, the mean monthly income was that, and the standard deviation was that. Assume the monthly incomes are normally. Is that a means or a proportion problem?
I think that's a means problem.
It is, because it says the mean monthly income, right? Now, if it said the average monthly income, it would still be a means problem, right, guys? So the first thing when you're looking at a confidence interval, let me pull this down. So the first thing when you're looking at a confidence interval problem is you have to decide, is it a mean or is it a proportion? That's the first thing you have to decide when you're looking at a, let me pull this back up. When you're looking at a problem, you have to decide, is this a means problem or is this a proportion problem? So in a random sample of 7 aerospace engineers, the mean monthly income was $6,824. Standard deviation was 340. Assume the monthly incomes are normally distributed. So if I was doing this one completely, besides knowing that it's a mean, what else do you have to know? Once you've decided it's a mean, you have to decide what?
If it's greater than.
Now you're thinking about chapter 8. If we were doing a hypothesis test, we'd have to figure out if it's greater than, less than, or not equal. But for a confidence interval, we don't have to do that. So knowing it's a mean, we know it's, mean is less than, we're going to have here and here. But what do we have to decide before I start going to the table and stuff?
Do we have to find the sample size?
Well, we would if we were completing the whole problem. I talked over somebody. What'd you say?
Sorry, the T chart, like if you're using that or the Z chart.
Yep, exactly. There you go. We have to decide whether it's a T or a Z. So is this a T or a Z? In a random sample of 7 aerospace engineers, the mean monthly income was this, the standard deviation was this. Did they give us the sigma or did they give us the S?
Sigma. Standard deviation.
They did give a standard deviation, but is it of the sample or is it of the population?
It's the sample.
It's the sample. So in this one, we did not have a sigma. They're giving us the S. So it says in a sample, the standard deviation is this. So this is the S. So if we have an S, then we're going to do, let me close that up. So if it's an S that's given, then we're going to use a T test. And if it's the sigma, we're going to use a Z, right? And what about if it's a proportion?
I think we go to the T test and go down to the Z.
Yeah, it's all on that same chart. It's just whether you go to the bottom,
okay.
which is the Z, or if you use the degrees of freedom, which is the T. So yeah, we do the Z, which is all the way at the bottom. Okay, so that's when you're doing a confidence interval or a hypothesis test. You've got to know, the very first thing you have to decide is it mean or proportion? And if it's mean, am I doing a Z or a T? Because otherwise you're going to look at the wrong spot on the chart. So go ahead.
The T chart, I'm trying to find my chart. I can't find it. You said instead of going all the way down, you go like if it's 0.05, is that the one tail, two tail thing?
Well, not for confidence intervals. One tail, two tails for hypothesis testing. And so for confidence intervals, you just have to decide whether you're going all the way to the bottom. I'm trying to pull up my chart here just a second.
Oh, that's where you take in minus whatever, and then you go down. Okay. I'm good. I'm good. Got that.
I'm trying to pull up my important formulas and tables chart here. I don't know why. Again, I thought I had everything pulled up that I wanted, but I don't. So let me pull this up really quick. So for confidence intervals, if you remember, confidence intervals has its own row at the top. And so for confidence intervals, you just have to decide if it's what the percentage is, and then whether you're going all the way to the bottom or if you're going to stop. Now that problem didn't have all the information. This one we couldn't have done a whole confidence interval on because it didn't have everything. But it would be what you would have to do. So if we were on this one, once you decided whether it was a Z or a T, then you have to go to the top row here, confidence interval. So all of chapter 7 will use this top row. And so then you would figure out what percentage it was. And if it was a Z, you'd go all the way to the bottom. And if it was a T, you'd use, your degrees of freedom. Does that make sense? Everybody good now? We haven't done confidence intervals for, at least a week now.
It's degrees of freedom where you do n minus the
n minus 1.
Okay.
Yeah, it's always just one less. I've never quite understood. I don't know why they don't just make the table. I mean, they could make the table so it had n in it instead of degrees of freedom. I don't know. I'm sure it's probably for something further that it matters, because sometimes you do determine the degrees of freedom differently in some more upper level problems. So that's probably why. Okay, so let's see what this next one has. All right, determine which distribution to use, if any. So are we using, oh, we already talked about this. Is this a Z or is this a T? So we would use Z if the sigma was given, and we would use the T if the S was given. Okay, so on this one, remember what they gave us was they gave us the sample standard deviation. And so because they gave us the sample standard deviation, we want to do a T distribution. So that's what that was asking for. So if it's a mean and they give us the S, we're going to do a T, and if they give us the sigma, we're going to do a Z. And then back to proportion, we're going to do Z again.
And the Z is on the T chart though, kind of, right?
Right, the Z's at the very bottom. It's it even has it listed on the chart. It says over here, it says Z. So see right here where it has that. So you can get this off of the Z chart. It's just harder. If you get it off the Z chart, you have to look like in the body of the chart for the percentage and then go to the outside columns or the outside margins to get your Z. It's harder. So since all I'm going to give you is the ones that are listed at the top here, no sense in messing around with that whole big Z chart when they're listed right here. So did that answer what you were wondering?
Yes.
Okay. So let's, oh, this darn thing. I can either have the drawing tool or I can have the mouse. If I have the drawing tool, then I have to click back to the mouse to click anything. Okay. Those look like years instead of scores. Okay, so this is one where you want to look up on the chart. So try to see if you can find the T sub alpha over 2, 95% confidence interval for this problem. And I'll pull the chart up here in a second. But remember the things that you're looking for when you look at the chart. We know it's a confidence interval. So you know what row to look at the top. It says it's 95%. We're doing a T, and it's a sample of 7. And I'll pull the chart up here in a minute if you don't have the chart, but if I go to the chart, then people can't see the answers. All right, I'm gonna go to the chart real quick here. So remember, it was 95% confidence interval. 95% confidence interval. It was a T, and there was a sample of 7. Good. Okay, so we had 3 out of the 6 people get it right. Let's look at the chart. 1.96 would be if it was a Z. And this one I think is 1 over from where we're supposed to be. So remember, it's a T sample 7, 95%. So let's pull this up. So 95% sample size 7, and when we're doing the T, that means we use degrees of freedom, so it's this one. Oh no, the 2.365, you forgot to subtract 1. So since it was sample size 7, that means our degrees of freedom is 6. Even if you didn't get it right, is everybody okay with that now? That makes sense. I have this minimized. Oh my goodness, what did my computer just do with that? I just did something crazy. There we go. Okay, so everybody good with that now? Alrighty. So let's go to so 2.365. If you picked that one, it's because you forgot to subtract 1 from the sample size. And the 1.96, you did a Z instead of a T. You went all the way to the bottom when you were supposed to stop. Okay. So this one actually has you do the whole thing. So the one that we just did, they want you to actually do the whole thing. And like I said, it doesn't give you enough time. So we'll just kind of start working on it while it's doing its thing. So remember, you're going to have mean in the middle. You're going to put your X bar, subtract your T sub alpha over 2. And then you're going to multiply that by S over square root of n, right? I think that's right. Let me pull that up. Pretty certain that's right. Yeah, S over square root of n. So it's this formula right here. So that's what you should have had plugged into the formula. Your average was 6,824. Your T sub alpha over 2 we found to be 2.447. I think that's right. And then the standard deviation was 340 and the sample size was 7. And then we do the same thing over here, but with a plus. Good, one person got in under the wire. And that is the correct answer, but let's keep working it out. So is everybody okay with the numbers that I have in there? It's been a bit since we've done confidence intervals. 2.447 was correct, wasn't it? Is that the right number? 2.447, yes. Okay, so this is the formula. You guys are good with where to find the formula at all? Let me know if not. And then the X bar is whatever they say the sample size is, or the sample average is. So in this case, the sample average was 6,824. And then the T sub alpha over 2 was what we found on the chart, the 2.447. And then the S is 340. That's the sample standard, or that's the sample standard deviation. Yep. And then the square root of 7 is the square root of the sample size. Is everybody good with where the numbers came from?
So you round these to the nearest whole number, right?
I mean, it just depends on the situation, but in this one, yes, because the average was given as a whole number.
Oh, so you're gonna round whatever the average is.
Right. But remember on the test, you're gonna get choices. So it's, you'll see what it's supposed to be rounded to because it'll be whatever I have it rounded to. On the test, the thing is occasionally when, even if you're doing a Z or a T, sometimes it gets you the right answer, even if you're doing the wrong one because they'll be close enough. So make sure when you pick your answer that you look to see if it has degrees of freedom. Like this one should have, again, I can't remember exactly what order I have them in. I should have looked right before I got on with you guys. I didn't think to. But it has like like for A, it asks you to do what's X bar. And then for B, it asks you what's your T sub alpha or your Z sub alpha. And then for C, I think it asks you for the degrees of freedom. And then D is, I think S, it says sigma or S. And then E is the final answer. So for this one, you would want to look for, you know, the one that said 6,824, 2.447. Degrees of freedom would be what?
6.
6, yep. And then D, the S or sigma would be 340. And then your final answer would be 6,510 is less than the mean, is less than 7,138. So you would want to look for this as the choice that you pick.
When I'm doing the T to the whatever that D to divided by 2,
It's a sigma
number,
or an alpha. I mean, go
when
ahead.
I multiply that by the 340 divided by 7, I'm getting 118.85.
Okay, let me see. So I have 340 divided by square root of 7. That's 1.28, and then take that times 2.447.
I get 314.45 for some reason.
I got the same thing.
That's what I got.
Yeah. So try that again, Leo. I think that's who was talking. I'm pretty sure that was who was talking. So you should get 314.458.
You think on my calculator I shouldn't do? I did it all at once, the 2.447, then like that. Wonder if I shouldn't do that.
Well,
did you put the 340 in parentheses and stuff? Because that always helps when I do it. Because if I just put it in like all together, it's staggered, if that makes sense.
Oh, wait, is it the square root of 7?
Yep.
That's it. I just did divided by 7.
Yeah, that would make a huge difference. So yeah, you should get that. And then of course that rounds to 314. So it ended up doing 6824 minus 314. And then 6824 plus 314.
Okay.
And that's your margin of error. I don't ask that on the test. I never ask you what's the margin of error, but you know, in your homework or whatnot, if you're running across something, that's what they mean by margin of error. It's what you added and subtracted. Okay, so now the next one, I think we go through the same kind of process here on the next problem, but it's a different, you know, this was a mean with a T. So I think this next one, it's just something similar but different type of problem. Okay. Uh-oh, Vinay, you're down to second place. All right. So determine whether this is a means or a proportions problem. So same thing. In a survey of 1,037 adults from the US, age 65 and older, 643 were concerned about getting the flu. Oh my gosh, this is slightly pertinent. So good. So it's because it's asking about what part of the whole. So in this case, since it's saying that 643 out of the 1,037, that's a proportion. What proportion out of the total were in the category that you're looking for? So it's 643 out of 1,037. What's that called? Do you guys remember what that's called? Once you calculate that? We'll cheat. This might be one of the upcoming questions, but we'll still figure it out.
Isn't it p hat?
Yep. So it comes out to be 0.620 approximately, and that's called your p hat. Yep. So this is a proportion, and this is a p hat in your problem. So we'll go and look at the chart here in a second for that. But you guys okay with that? Even if you missed it this time, it's okay. We haven't done it for a bit. Are you okay with why it's a proportions problem? Okay. And So when we're doing a proportions problem, I think the next question asks you what kind of test or what kind of confidence interval you're going to do. Okay. So which distribution are you going to use? Are you going to use a Z distribution, a T distribution, or neither one of those for a proportion?
A Z.
You are correct. Perfect. So if it's a mean and they give us sigma, we use Z. If they only give us S, we use T. That's the only time we use T. And then if it's a proportion, we go back to using Z again. So you're correct. Since it's a proportion, we're going to do the Z distribution. Perfect. Get rid of this or it'll be in the way of the next problem. I think we can leave these up here. It'll be okay. All right. So now we need to figure out the Z sub alpha over 2 for 90% confidence interval. I'll pull the chart up. So it's 90% confidence interval, and we're doing a Z. So you're looking at your chart at 90%, and because we decided we're doing a Z, we don't have to worry about the degrees of freedom. We can just go to the bottom. Okay, perfect. So we've got we'll write this down here. So our Z sub alpha over 2 is 1.645. And we got that from knowing, since it's a P, we're doing a Z. That looks kind of like a T. Let me fix my Z here. Okay, so since we know it's a P, we're doing a Z, we go to the chart and we pick 90% confident, and we go all the way down to the bottom, and that's 1.645. So that's what we're going to use for our Z sub alpha over 2. Everybody good so far?
On the test, are we going to have to round it to the 2 decimals, or is the 3 fine?
Again, I give it to you.
Okay.
So I think I did the 3, if I remember right. So it'll say, you know, one of your 4 choices will have Z sub, or it'll have 1.645. So if this was the problem. So if this was the problem, so far the correct answer would have, I don't know why I keep writing that wrong. So on this one, I think the correct answer would have something like, I don't know. Can't remember what I did all for Z, but it would have like, oh, I know. The first one says what's P hat, Q hat. So it would be 0.620 and what is that, 380. So you have to figure out the P hat and the Q hat. And then the next one asks you for your degrees of freedom, or these might be flipped. And then it asks you for what's this T sub alpha over 2 or the T sub alpha over 2. And then the last one will be the answer. So here's the P hat, Q hat. You guys okay with that one?
How did you find the Q hat?
That's always 1 minus.
3, 4, 5.
Oh, it's 1 minus P hat.
Uh-huh.
You get Q hat. Okay.
Yep.
Gotcha.
And so your correct answer would have 0.620 and 0.380. Degrees of freedom would be what? What's our degrees of freedom when we're doing this problem?
It's the, oh wait, no.
There's none, right? But I don't really want to give that away on the test. So there'll be choices where I actually put a degrees of freedom on there, you know, which I guess would be 1036 in this problem, but we're not using degrees of freedom. So there is no degrees of freedom. So your answer for that one would be none. And then your z hat or t hat would be the 1.645. I just don't want to give away that this is a z problem by not asking you what the degrees of freedom is. So one of your choices on the test, it'll say this, none for degrees of freedom, and then your z sub alpha over 2 will be 1.645. And again, what you're going to do is you're going to work it off to the side, and when you come to pick it, you're going to be like, oh, there's my z sub alpha over 2. Oh, that's because I didn't have any degrees of freedom.
So the only time that there's a degree of freedom is if it's going to be a T problem.
Yep, that's the only time that you do degrees of freedom.
Ah.
Z's are always at the bottom. Okay, so let's write down what the formula is before we get to this next problem, because otherwise we're going to be scrambling. I'm pretty sure the next one asks us to calculate it. So we got all our info, and so to calculate the interval for a p, we're going to go to chapter 7, and here's our formula. So it's this formula right here, confidence interval for a proportion. So we're using that formula. I'll write it off to the side here. So it's p hat minus z sub alpha over 2 times p hat q hat over n, and that's whoops, that's supposed to be a square root over that whole thing, not just a parentheses here. Square root of that, and then that's going to be less than your p is going to be less than your, we'll have the same thing on the other side. So plus the same thing over here. So let me get rid of that. And we'll go back to our thing. And I'm pretty sure that's what the next problem just asks you to calculate this. So if you want to start putting your numbers in. So yeah, construct a 90% confidence interval for the true proportion.
And do I round the z through alpha to 3 decimal places?
It shouldn't really matter. It should come out the same answer. It should come out close enough that you'll know which one's right. I'm going to erase this because it's in the way. I'm going to rewrite it. On this one, I'd work from the inside out on this one. Yes. Oh, and I wrote my problem right here wrong. That doesn't have a. Okay, so you should have done 0.62. And keep working on this if you ran out of time, it's okay. The longest I can give is 2 minutes. So 0.62 times 0.38, and then divide that by 1037. This is the order I do it in anyway. And then I do the square root of that answer. And then I multiply it by 1.645. So what did you guys get for that one? What did you guys get for the margin of error? What did you subtract?
I got 595, like 0.595.
Ooh, I didn't get that.
No, we got 0.025 if I round.
Oh, yeah. My bad. I was talking about the answer.
Oh, yeah, you're right. So it's 0.025. So this comes out to be approximately 0.025 if you take again, I start on this one. I start on the inside because of the square root. So I do 0.62 times 0.38. I divide it by 1037, hit equals. Then I do the square root of the answer, hit equals, and then I multiply that by 1.645. That way I just don't have to worry about if I'm doing the order of operations right. I know it's doing the inside before it's doing the square root and all that stuff, and it's doing the square root of the whole thing. So yeah, then if I take this and I go down 0.025 and up 0.025, I get this one. So I know it's been a bit, but now that we've done 2 of the confidence intervals, are you guys remembering how to do these? These are easier than hypothesis tests. It's just plugging the numbers in. It's not quite so much of a, there's not so much quite level of thought process as far as having the 5 steps and all that. Anybody have any questions on that one? Okay. You guys feel better or worse now that we've done a couple? Are you remembering them okay? And you're like, oh yeah, I remember how to do these? Or are you like, I have no idea how to do these?
I feel better for sure. Like these, you can just plug them into the equation, right? So
Yeah.
like,
Chapter 7 is definitely more just plug it into the equation kind of problems. And you know, even though chapter 8 has a process, at least it's like a similar process every time. It's not like it changes dramatically. So, all right, let's see what the next one is. I think there's actually not that many questions on this Kahoot, so I think we're getting close to the, oh, this is number 9. Oh, so now this one's a different one. This is find the minimum sample size. So here we're looking for the N. You want to find the mean repair cost for dishwashers. The estimate must be within $10. Determine the sample size needed to construct a 99% confidence interval. Assume the population standard deviation is 22.5. So let me pull up. If you do not have the chart, you are lost right now because you can't look it up. So 99% confidence interval, and it's always a Z when you're trying to find the N because you don't have the sample size. So 99%, and we're going all the way to the bottom here. This is your Z, 2.576. And then we've got to go up to the formula. And it's this formula right here. So N equals Z sub alpha over 2 times your sigma over E, and then you square that. And we just said that Z sub alpha over 2 was, oh my gosh, what was it?
576.
2.576, thank you. I know, you guys couldn't see the answer, sorry. So our Z was 2.576. Are you guys okay with where that came from? Oh shoot, I didn't mean to erase that. So our Z sub alpha over 2 was 2.576. Is everybody okay with where we got that from on the chart? 99%. 99% confidence interval, and since we're doing an N, it's going to be a Z, because you always do for N, you do Z sub alpha over 2 times sigma over E, and then you square that. Okay, so what do you guys, besides the Z sub alpha over 2 being 2.576, 2.576 or 2.567?
576.
576, okay. And then the sigma is what?
22.5.
Got it. And then the E is our $10. And then you square that. The nice thing about doing the test as a multiple choice question, or multiple choice test, is when you're doing the test by hand, I'll have people that'll try to, on these problems, they'll try to do a confidence interval. They'll get it mixed up and they'll think they're actually supposed to do a confidence interval, but you can't mix it up on the test because I give you just like a single digit answer. So there's no way to mix up which kind of problem it is. So a little bit of a bonus. Got to be some bonus in this whole mess, right?
If you get so for these, if you get like a 0.6 or 0.7, you round it up to the next whole number, right?
Right. So this one comes out to be 33.59 or 33.6. So we say 33 or 34.
34, because you never round down, right?
Right. You never round down on these. You always round them up. So, yep. So it's going to be 34. And can you guess what one of the distractor answers is going to be on the test? That's going to be the rounding down. So you've got to remember that on these, you're going to round up no matter what. You don't say 33.59. I don't think on the test, I don't think I gave you the decimal. I think I gave like 33 and 34 as answers. But you always want to round up. Even if this was, you know, say it was, I don't want to put it there, but let's say it was 33.2, you would still say 34, right? Because this is the minimum sample size needed. So you can't go down to 33, you have to go up. Because if you go down to 33, you're below the minimum. Everybody good on that one? Okay. I'm pretty sure the next question, if I'm remembering correctly, is on sample size, but it's for a proportion. So let's just write our formula down really quick. Let me clear this out. So it's one of these. It's going to ask what's the minimum sample size, but it's for a proportion. So let's write it over here. So it's n equals p hat q hat times z sub alpha. Whoops. And I don't know what my up with my writing today. I'm like doing everything backwards. Z sub alpha over 2 over e squared. So there's our formula. And I'll pop over here to the chart real quick to get the Z once we figure out what our confidence level is. All right, so find the minimum sample size needed to have a 4% margin of error with 99% confidence. 99% confidence is the same. It's 2.576. Yeah, same number, 2.576.
What was E again?
That's the margin of error. That's what you want to be within. So in this problem, it's the 4%. But what do you put in for 4%? Do you put in a 4?
No, you put 0.04.
Yep, you got it. So this is the one we did before, and I think the numbers are the same. So our p hat was 0.62, and our q hat was 0.38. And then our z sub alpha over 2 is 2.576 with a margin of error 0.04. And then you square that. I think that's right, isn't it? Does anybody see anything wrong with that?
And the 0.62 comes from the
That's the same way that we figured out. We used this one on that first problem. This is the 640
divided by.
Yep. Sometimes they'll give it to you, but if they don't, you have to calculate it. So in this case, 643 divided by 1037 was about it was 62%-ish. It was like 0.6200 something, which that's your p hat, and then your q hat would be 1 minus that. So you get 0.62 and 0.38 for your p hat and q hat, and then the z, the margin of error, and square it. Is the answer right? I always worry on these.
I'm getting 980, but I think it's because I rounded the 2.576 to 58.
I got 977.11, so I would think it would be 978.
Yeah, technically it should. Oh, you know what? I bet it's because, I bet when I did this, I did 2.58.
Oh, okay.
2.576. I know on the test I used the 3.04. Square that. And then multiply by 0.38 and 0.62. No, well, yeah, you're right. I mean, 977, yeah, it should have rounded up to 978. I think what I did is, I think when I did this problem for the Kahoot, I think I did 2.58. 0.38 times 2.58. And so it does make a little bit of a difference. So go ahead and use the 3 decimals on the test just to be safe. If anything were to come back where I've made a mistake like that, like if you were to show me, no, that got 980. 977 is just wrong. It should have been 978. So I don't know what, that was just a mistake. Somehow, I don't know what I did. But it's the only one that was even close, so I guess there's that. But it should have been 978 because it came out to be 977.1 something. But is everybody okay with the process of calculating it? You guys good? Okay. So there'll be a couple of those on the test as far as, like I said, I think there's 3, if I remember right, I think there's 3 where you actually do the confidence intervals. And then I think there's 1 of each of these. So there's 2 where you figure out what the n is. And then I think before those, there's a couple that are like true, false, multiple choice, you know, just basic answers. So there's a couple of those. Then there's like 3 actual confidence intervals and a couple where you have to find n. So what is that? About 7 questions out of chapter 7. I think like I said, I think the whole test only has like 15 questions, something like that. Might even be less than that. Because then I know in chapter 8, there's a couple of the true, false, multiple choice type. And then there's 3 hypothesis tests. Is that right? 7, 8, 9, 10, 11, 12? Yeah, I think there's only 12 questions on the test, actually. So, all right, let's look at the next one. Get all this mess up here. Okay. So here's a good question. As the sample size increases, what happens to the confidence interval? If you have a bigger sample size, is that better or worse? And what does that do to the confidence interval? What's a better or worse confidence interval?
Wider.
Well, so let's have that discussion. So what what happens is a bigger sample size better or worse? That's better, right?
Right? Yeah.
Yeah, a bigger sample size is better. So what's a better confidence interval? A wider one or a narrower one?
I guess narrower, because
Yep.
it would narrow down the answer to more correct.
Yep. So we can have a smaller confidence interval if we have a better sample size. So it's this one. So it makes it narrower. This could be a good question, one of those multiple choice, true false kind of ones. So there's a couple other things that could happen. If the sample size gets smaller, that's worse, right?
Oh, okay.
And so that would make the confidence interval get wider, right? Because in order to be confident with a bad sample size, we just have to get a bigger net. Think of the net idea. So if we have a bigger sample size, that's better, so we can use a smaller net. But if the sample size is worse, then we just have to use a bigger net to try to catch the actual population standard deviation, or population mean, or population proportion. So the other thing that affects it is your confidence level. So if you have your confidence level, if you have your if it goes from say 90% to 95%, is that magical that oh wow, I'm 95% confident now? All you do when you do that is you'd make your confidence interval wider, right? So if you increase your confidence level from 90% to 95%, all you do is widen your confidence interval. And then the same the other way. Like let's say you were at 99% and you lowered it to 95%. All that does is, if we want to be less confident, then we can narrow the net. We're going to be less confident that we're actually going to capture the fish, the mean or the proportion. So we're allowing for less confidence, but that narrows up our confidence interval. So
Is that what you're saying? Wider is better. We get more of a. Is that what you're saying?
no, when it's wider, it means to have it narrower is better because it's more exact.
Okay.
Yeah. So to have a narrow confidence interval, like if somebody said, what's the average number of credit hours that a student has? Well, would you rather be able to tell the person that the average number of credit hours that let's say a sophomore, what would that be? Maybe 10, 20, maybe 40-ish. Okay. So would you rather be able to tell them it's somewhere between 30 and 50? Or would you rather be able to say it's somewhere between 35 and 45?
The second one.
Yeah. So narrower is better.
Okay. And so when the confidence, but yet the confidence as it gets lower is actually when it becomes narrower. Is that correct? So 99% means it's wider.
Right. Because if you want to be more confident, you widen up the confidence interval.
Okay.
All you do to be more confident is you get a bigger net. So to be more confident, you need a bigger net.
Okay.
So that could be, that could be one of the multiple choice true false questions for chapter 7. Would be something about standard deviation getting better or sample size getting bigger or smaller, or the confidence level getting bigger or smaller. How does that affect the confidence interval? So that would be a very valid true false multiple choice question. Okay, let's look at the next one. I'll leave all this stuff on here. It might have something to do with it again. Yeah, there you go. So as the confidence level increases, what does that do to the confidence interval? So if you want to go, say, from 90% to 95%, perfect. Okay, good job. So as the confidence interval or the confidence level gets higher, then you're going to widen your net up to be more confident. So if you want to be more confident that you're going to catch the fish, you get a bigger net. And that confidence interval is your net. All right, I think that might be, is that the last question? I can't tell. Got so many things going here on the screen. Oh, one more. So a confidence interval is the what plus or minus the what. So what is that thing? The key here is probably the second blank. What are you plus or minus? So when we start these, we always have the mean or the proportion, and then we subtract something here, and then we add something. I actually shouldn't say mean. We actually have this mean, the sample mean or the sample proportion. And so what we have is we have a point estimate. So our point estimate is whatever we get from the sample. Okay, and then we subtract the margin of error and we add the margin of error. So we start with our, let me do it as the two different things instead of trying to merge them into one. So if we have mean, we start with the sample average. Ooh, those were all over the place. Okay, so this is what this is trying to get at. So you start with your sample average, and then you subtract the margin of error, and you add the margin of error. So remember, your X bar is your point estimate. And then if you're doing proportion, you start with your P hat, and you subtract the margin of error to try to estimate that proportion of the population, and then you add. So you either have an X bar or a P hat, which is your point estimate, your sample average or your sample proportion, and then you subtract and add the margin of error. So that's what that was kind of trying to get at. That could have been one of the multiple choice questions, but it's not. But does everybody understand what it was getting at? Does that make sense now? I think everybody was wrapped up in the wording of that. The wording of it was kind of weird. But you start with whatever either the sample average or the sample proportion, and then you add or subtract the margin of error. All right, I'm pretty sure that was the last question. Here we go. All right, so that actually took us quite a bit. Let me see if I can find one more problem that we can do as kind of a wrap up. Ooh, that's playing a really loud song in my head. Let me leave this. Whew. So is everybody still there? All right, so let me close this up. Is it just the 5 of you left? Hopefully not. It's probably just not showing everybody. Oh no, there you all are. Had me worried there for a minute. I was like, I scared everybody off. It was so bad. All right, let me pull up the book really quick. And and we'll do one confidence interval beginning to end. Here's the problem, let's work the whole thing. So instead of doing it all in the parts and everything, we'll just do everything. So I should be able to pull this up pretty quick. Give me just a second. I've lost my mind. I just almost couldn't remember the name of our homework system. All I could think of was my math lab, and that's the wrong one. Okay, so I'm going to do this a little bit different than, I'm not going to pull it out of the actual Connect Math problems. I'm just going to pull it out of the book. So where are you guys at? Okay, so let me share this screen again. We're just going to go to our ebook, and I'm just going to pull up chapter 7, and we'll just grab a problem. Hopefully it'll be a good one. So we'll just go to the end of chapter 7. And again, you guys can do this. Remember that your ebook is just like any other book, and it has like like a quiz and a practice thing at the end of it. It has the answers to the odds at the back and things like that. So all right, let's just grab this one. I don't know which one this is, but we'll go with it. So let's do number, whoops, that's not what I wanted to do. No snipping. Let's go with number 13 here. Okay, so doctor visits costs. It says an irate patient. Can you guys all see that? Or is it too small? See if I can make it bigger. Ah, there we go. Okay, so number 13 there. So a doctor visit costs, an irate patient complained that the cost of a doctor's visit was too high. She randomly surveyed 20 other patients and found that the mean amount of money they spent was $44.80 and the standard deviation of the sample was $353. Find a point estimate. Don't worry about that. That's just finding that's just $44.80. So find the 95% confidence interval of the population mean, assume it's normally distributed. Okay, so before we start, what's the first thing you have to decide? It's asking you to do a confidence interval. So before you do a confidence interval, what do you have to decide?
Which one it is?
Which one of what are our choices?
Proportion or proportion?
Yep, proportion or a mean, right? So is this a proportion or a mean?
Is it proportion because it says standard deviation of the sample? Or no?
That's important that it says standard deviation of the sample, but that doesn't make it a proportion. Proportion is like a percent.
So it's a mean.
It's a mean because it says the mean amount of money they spent was $44.80. So it's a mean. So now go back to what you were saying about the sample standard deviation. Did they give us sigma or did they give us S?
They gave us S.
S. The standard deviation of the sample. This is an S. So they gave us an S, which means we're going to use what? Use the T, right? This is Z. This is also Z. But if we have this one, we have to do T. And try to do that. I know it's really like your instinct is to like jump in and start working right away. But you have to stop and figure that out before you can start working because you have to know what formula you're using. So we're using the formula for mean using a T. So that's X bar. It's on the thing, but I won't pull it up right yet. So it's X bar minus T sub alpha over 2 times S over square root of N less than the mean less than X bar plus the same thing. So go ahead and fill everything you can in before we go. Well, actually, let's just go ahead and go to the chart. So T sub alpha over 2, what are we going to look for on the chart in order to get our T sub alpha over 2?
So 95%, but then 20 minus 1, so 19.
So a 19, so a confidence interval, or a degrees of freedom of 19, perfect. So a 20 means our degrees of freedom is 19, and we're at 95%, perfect. So pull that up. 95%, 19. So we're right here in this middle column, right here. So 95%, degrees of freedom 19, because our sample size was 20. So that's our T, 2.093. 95%, degrees of freedom 19, 2.093. 2.093. And what's our X bar?
44.80.
You got it.
So whenever you do a T, you have to find degrees of freedom.
Yep.
For any.
That's what the degrees, that's what the T, it adjusts for the fact that we only have the S by doing the degrees of freedom. If we have the population, like, yay, we can just go down to the bottom. It's like a better deal. And then we can use a Z for P because P doesn't really use standard deviation. So we don't have to worry about it. Okay, so on this one, our S then is 353, right? And like you said, our sample size is 20. So that's what you're typing in. And then it would be 44.80 plus the same thing on the other side. What's that margin of error, guys? What are you getting for that? 3.53.
1.65.
Everybody, are other folks getting that? Yeah, that's what I got.
Yes,
1.65. Perfect. Okay. So 1.65. So we're going to take that 44.80 and subtract $1.65 and add $1.65 to get our net. So what is that?
3.15.
43.15. Okay. And then over here we got 40.
6.45.
45. Okay. So our confidence interval is between 43.15 and 46.45, which is pretty good considering we only had a sample size of 20 people. Still not bad. Somewhere between $43.15 and $46.45 for an average of how much they spent for a doctor's visit. Again, on the test, since I can't be, since I can't do it, have you guys write all this out, what it'll have on the test is, like I said, I think A is what's your X bar. And so you would, you look for the answer that has 44.80. So it'll say, what's your X bar? Then it says, what's your Z sub alpha or T sub alpha? So you'd look for the one that had what?
$2.093.
Yep. So you'd look for the answer that had 2.093. And then degrees of freedom, you'd look for the one that had.
Wait.
19.
You got it. And, for this one, it'll usually have like 19 or 20 will be the choices. So just make sure you're picking the degrees of freedom 19, not the sample size 20. And then for your S, you're going to put the 3 point, you're going to pick the one that has 3.53, and then E will be your answer.
So we pick all of those on the test?
I have 4 complete ones that are complete.
Oh,
So
okay.
you just have to look for the one that has all the right answers in it.
Okay.
So what I would recommend is just do this. Don't worry about what the answers are. Just do your confidence interval and then look for your correct answer. I usually don't have this one wrong. It's usually, you know, the ones that vary is like, do you have the right degrees of freedom and the right Z or T, you know. And like I said, if you pick this wrong and you do Z instead of T, and then say the degrees of freedom is none, you miss like 1 out of the 3 points. You don't completely mess it. You don't miss all 3 points. So, you know, you want to be accurate, want to do as best as you can, but the ones that have the common errors in them, I tried to adjust the points so it was about the same as what I would have taken off if you'd done that on your own. So, you guys want to do one more? Let's do one more. If you don't want to do one more, here's the beauty of Zoom. If you don't want to do one more, you can leave. And I won't even notice, right? Probably. Okay, let's do one more. Let's do one that's got that's different than that one. What if let's do 22. And then we'll call it a day. So television set ownership, a survey of 90 randomly selected families showed that 40 owned at least one television set. Find the 95% confidence interval of the true proportion of families who own at least one television set. So what's the, what are we doing here? Are we doing a mean or are we doing a proportion?
I mean, it says proportion, right? So proportion.
Yep. And it really does, like on most of the problems, it'll actually say usually, find the confidence interval of the mean or find the confidence interval of the proportion. So it's a proportion, and we're doing proportion. We always do
Z.
Z. Okay. And let's see if I can remember what the formula is. It should be P hat minus Z sub alpha over 2 times the square root of P hat Q hat over N. That's on your card. You don't have to memorize it. I've just done it so many darn times that. A 95% confidence interval. Let's see if we can find the Z before. Okay, so 95% confidence interval when you're doing a Z, that's our ever used 1.960. 95% confidence interval for a Z, 1.96. So what'd you guys get for P hat? I don't want to leave anybody hanging here.
Is it 0.44?
And you got that
That's
from,
what I got.
and you got that from,
40 minus 40 over 90, right?
yep. And I would use 444. Usually they say with the proportions to do 3 decimal spots. So it's like 44.4%.
Okay.
So I'd use 444. Which then leaves Q hat to be 0.556. I don't like that blue. Ooh, I did something wrong. And if something doesn't seem right, if you're like, that doesn't really work, or doesn't really look like the answers I've gotten for other problems, double check it. Like I just forgot to do the square root. And I was like, that does not look right. What'd you guys get here for your margin of error?
0.103.
Before you
yeah.
subtracted.
Oh.
You guys get 50.053? No, 52. Were you guys getting that?
No.
No?
I was getting the 0.103.
I think that's too high. So it should be, you guys okay with where the p hat came from? P hat's the 40 over 90. And then we're okay with the 1.960. And then that makes, again, p hat 0.444. And that makes q hat, if you take 1 minus 0.444, that makes q hat 0.556. And then that's over 90. Let's double check. I might be wrong. 0.444.
Getting it. I keep getting 0.103.
Yeah, I think that happens after you multiply by the 1.960.
Oh, that would probably be helpful. Okay, so.
Because I got that too.
I might have messed up here, guys. So square root answer. Oh, you're right. I forgot to multiply by 1.96. Okay, thank you. Thank you for insisting that that was not right, because that's not right. Okay, so this comes out to be 0.103.
Yeah.
That's what you guys were saying, right? Okay.
Yep.
So 444 plus 0.103, and then we've got 0.444 minus that, which is 0.341. And then plus that, which would be 547. Is that right?
Yep, that's what I got. Now, would you want us at all to like make those whole?
No, for percentages, for the proportions, it always says 3 decimal spots. So like, again, because if you took this as a percentage, it'd be 34.1% and 54.7%. So it's like 1 decimal spot for the percentage.
Okay.
And so then when you were looking for the correct answer, it would say something like, I think it asks, what's p hat, q hat? What's your z sub alpha over 2 or t sub alpha over 2? Then it asks for your degrees of freedom, and then it has the actual answer for the ones that are proportions. So your p hat, q hat would be, you'd look for the one that had 0.444 and 0.556. Then look for the one that has what for the z?
1.96?
Yep.
Yeah.
And degrees of freedom would be?
None.
None. We don't use degrees of freedom because we're doing z. And then the answer would be this. So then it would have that for an answer. So you're going to look for out of the 4 choices, you're going to look for the one that has the correct p hat, q hat, the one that picked the z correctly, which means no degrees of freedom, and then your answer. So that's what you're looking for. For the confidence intervals, there's 4 choices. For the hypothesis test, there's 6 choices.
And you said, was it proportion that you said I should all round to 3 decimal places?
Say that again? Oh, yeah, proportion. But again, you don't really have to worry about that because all the choices are going to have the same thing.
Okay.
So, yeah. So if you're a little confused about that before you do your problem, you could always just glance at the answers for that if you wanted to. Just don't try to pick it out because then you're going to for sure mess something up. I'd go off to the side, go to your paper, work it out, and then try to find the answer that has all the right things in it that you want. So, all right, guys. I think we're going to leave it at that for today. On Wednesday, we will do hypothesis test. So I'm going to look at the Kahoot. We might be better served rather than doing the Kahoot. We might be better served to just pick some problems out of the book or something like that. So I'll see what I think will work best for using our time wisely.
Should I use the exam reviews in D2L, or do they have stuff we haven't learned?
No, they should be okay, except if you see, like, don't do anything out of chapter 9, and don't do anything where it says find the confidence interval of the standard deviation or find the hypothesis test for the standard deviation. That's what we didn't do. We didn't do chapter 9, and we didn't do. But yeah, you could do the review in D2L, and if anybody has any questions on Wednesday about the review in D2L, we could answer those too. I think what I might, like I said, I'll go look at the Kahoot, see how good it is. I think for the Kahoot, the hypothesis test was kind of hard to do because it's got all the steps. So I think what I'll do is I'll just have some problems to do. Maybe we'll do the one that's in the, I'll tell you what, let's do this. Make sure that before Wednesday, if you can, that you do in D2L, do the hypothesis test review. We'll start with that. That's what we'll start with. But I'll have some other ones ready to do too. So, anybody have any questions before we go? Other than happy studying and all that good stuff? Okay. Well, we'll see you guys on Wednesday. And if you do feel like you're ready, feel free to take the test, but we'll review chapter 8 on Wednesday. So, all
Okay.
right.
Bye-bye.
Bye, everybody. See you on Wednesday.